This is problem number 43, and we're going to solve it using matrices. So let's start by first setting up our augmented form. So I'm just going to go straight down the columns here. So the first column is going to be a 4, a 1, and a 2. The second column I'm getting from the y's, right? So this will be -4, -2, 1. And the third column will come from the coefficients of the z's. That'll be a 4, a -2, and a 3. Our vertical line for the equal sign, and then the constants, -8, -1, and 1. Close it off. Now what I'm going to do is I'm going to use the row operations to go from our original augmented form here to this one, from which I can read off the answer. So x will be 1, y will be 2, and z will be -1. Now, of course, the question is how do I get from here to here? All right, that's what we're going to do. I just want to show you where we're going. Here's where we start. Here's where we're going. So I want this identity matrix over here on the left side. 1's on the main diagonal, 0's everywhere else. So I'm going to use the row operations to go from here to here. So let's erase this one, and we'll start with with those row operations. So the first thing I want here is a 1 in that position. Now I could do this. I could interchange row 1 and row 2. Or I could just do this. I see if I multiply this, if I divide this by 4, all these are divisible by 4 nicely, no fractions. So I'm just going to do that. So I'm going to say row 1 is going to be the current row 1 divided by 4. And this is what we will get. So just divide every one of these numbers by 4. We'll get 1, -1, 1. There's our line, and -2. Rows 2 and 3 stay the same. 1, -2, -2, -1, 2, 1, 3, and 1. So I've now got the 1 in that top left position, and I'm going to call that my pivot. And what I'm going to do is I'm going to use row 1 and row 2 to get a 0 here, and then I'll use row 1 and row 3 to get a 0 here. So here's the plan. I want a 0 here. So it always works this way. What we're going to do is take the opposite of this number, multiply it through the pivot row. So row 2 is going to get replaced. Row 2 will get replaced with this. The opposite of that number multiplied through the pivot row. So it's going to be -1 times row 1, and then I'm going to add that to row 2. Now here's what it looks like. So take that -1, multiply it through each one of those numbers there. So we will get -1, 1, -1, and 2. I'll circle that. Let me just run a quick check. I don't want to make any arithmetic errors here. So multiply everything by -1. So I'll get -1, yep, 1, -1, 2. I think I've got it. And then what I'm going to do is add that to row 2. So I'll just draw an arrow. That's where I'm going. Then I want a 0 in this position. So I'll take the opposite of this number, multiply it through the pivot row. So the opposite of 2 is -2. So what we will have is that row 3 is going to become -2, right, the opposite, times the pivot row, through the pivot row, plus row 3. And that's going to look like this. So take that -2, multiply it through that pivot row. So everything gets multiplied by -2. So it looks like a -2, a 2, a -2, and a 4. I'll circle that. Let me just check those multiplications. So I'm multiplying everything in that top row by -2. So I'll get -2, +2, -2, +4. I think I got it. So that row is going to be added to row 3. So here's our new matrix. Row 1 stays the same. 1, -1, 1, our line, and -2. Row 2 is going to be the current row 2 added to this one. So component-wise, first plus first. 1 and -1 is 0. That's what we were after. Then second and second. -2 and 1 is -1. Then third and third, -2 and -1 is -3. And And finally, what do we have? Negative 1 and 2 is a 1. And then row 3, the current row 3, is going to be added to this new row 3 component-wise. So how about first and first? 2 and negative 2 will give us a 0. That's what we were after. Second and second. So we'll get 1 and 2. There's a 3. Third and third, we'll get a 3. And a negative 2 is a 1. And then last and last, 1 and a 4 is going to give us a 5. There's our second matrix. So the first column is done. I got a 1 and all zeros below it. Now, to the right and down, right? We want that diagonal. I want a 1 here. I've got a negative 1, so not too much work. What we're going to do here is this. Row 2 is going to get replaced with negative 1 times row 2, right? We can make that a negative 1 if you just multiply the entire row by negative 1. So I'm going to do that, and I'm just going to rewrite our new matrix. I can multiply that one in my head. So the first row stays the same, 1, negative 1, 1, and negative 2. And now change all these signs here, right? Multiply by negative 1. So we'll get 0, 1, 3, and negative 1, right? I'm changing the signs. And then the third row stays the same, 0, 3, 1, and 5. Now, I've got a 1 in that position, so that's going to be my pivot element. So what I'm going to do is I'm going to use that pivot into row 1 and row 3 and get zeros here and here. So I'm going to replace row 1 with row 2 plus row 1. Now, if you want to keep that opposite idea going, the opposite of negative 1 is 1. So this could be 1 times row 2, right? You send the opposite of this number through the pivot row. So 1 times row 2 is just row 2. So row 2, well, there's no change here, right? So I'm just going to write row 2. It's 0, 1, 3, negative 1. And in the next step, I will add that to row 1. Now, what about converting that 3 to a 0? Well, take the opposite, negative 3, multiply it through the pivot row. So row 3 is going to become the opposite. So negative 3 times row 2 plus row 3. And if I multiply all these numbers in row 2 by that negative 3, right? Negative 3 times row 2. So take the negative 3 right through here. We'll get, multiplying, we'll get 0, negative 3, negative 9, and 3. Let me just check those multiplications. So I'm multiplying everything in this row, the second row, by negative 3. So I'll get a 0, negative 3, negative 9, positive 3. I've got it. Okay, and then what I'm going to do is add that row to row 3. That'll be our next matrix. So here's our new matrix. Now the first row is going to be the current first row, right here, current first row added to that row right there. So component-wise, first and first is a 1 and 0 is a 1, all right? And then what? Second and second. So negative 1 and 1, that's a 0. Then 1 and 3, there's a 4 here. Then the last and the last, what do we get here? The last and the last is going to be a negative 2, and a negative 1 is a negative 3. Second row stays the same. 0, 1, 3, negative 1. Now the third row is going to become the current third row, right here, added to that row, component-wise. First and first, second and second, and so on. So 0 and 0 is 0. Then where are we? We're at second and second. Negative 3 and 3 is a 0. Then we're at negative 9 and 1 is a negative 8. Then last and last, what do we have? 3 and 5. Now, we're getting close. We've got a 1 and all zeros, a 1 and all zeros. Now, from that pivot over and down. We need a 1 in that position. Well, that's nice. I'm going to divide by -8, and both these are divisible by 8, so the plan is this. Row 3 is going to become the current row 3 divided by -8. So I just rewrote the matrix up here. I rewrote the first 2 rows. Now the third row, I'm going to do what? I'm going to divide each one of these numbers by -8. So 0 is divided by -0. So 0 is 0. -8 divided by -8 is 1. 8 divided by -8 is -1. And that right there is our new pivot element, right? I've got the 1s on the main diagonal. That one right there is our new pivot element. And the idea will be to use that 1 in the row 3 with row 1 and row 2 to convert the 4 and the 3 to zeros. So let's convert this 4 to a 0 by using our opposite idea. Take the opposite of that number, multiply it through the pivot row. So row 1 is going to get converted to the opposite, -4 times row 3 plus row 1. And it looks like this. So take that -4, run it through that third row, we'll get 0, 0, -4, and +4, right? I'm multiplying by -4, and then I'm going to add that to row 1. And then what about row 2? Row 2 is going to become, well, look at that number 3, take its opposite, -3, and multiply that through that pivot row. So it's going to be -3 times row 3 plus row 2. And running that -3 through that pivot row is going to give us 0, 0, -3, and 3, right, multiplied by -3. So we're going to add that row to our current row 2. So let's add these. I think this will be our final matrix. So what are we going to get here? That first row, that current first row is going to get added to this one. So first and first, 1 and 0 is 1. Second and second, 0 and 0 is a 0. Third and third, 4 and -4, right? 4, -4, there's a 0. There's our line. And last, -3 and 4 is a 1. There's our first row. And the second row, what have we got in the second row? All right, the current second row to this new second row, so component-wise. So second, the first component and first component. 0 and 0 is 0. Second and second. Over here, 1 and 0 is a 1. Third and third, so we're going to get a 3 and a -3, 0. And last, got a -1 here and a 3. That looks like a 2. Third row is the same. 0, 0, 1, -1. And now we are in row reduced echelon form, and we can read off our solutions, right? There's the x column, the y's, and the z's. So what do we get here? We get that 1x, no y's or z's, is 1. So x is 1. Then no x's, 1 y, no z's, so just 1 y is 2. And finally, no x's, no y's, but 1 z is -1. And we have it.